So you are ready, sir? Shall we start, sir? If you are ready,
Yeah,
means.
yes, sir, we can start. Yeah.
Yeah. Okay. Anyhow, I think maybe a few more people will join, so we will start up, sir, accordingly.
Okay.
Yeah. Okay. So very good evening to all present here. The speaker of the day, Mr. Pandya Raja, as well as the interns from various engineering college of Sriram, Agni, Satyabama, and Dhanakshmi College. It's indeed, I think it's a day 12. I think continuously 12 days we have been seeing the various sessions, what we have learned in our book. Much more, I think we would have learned in the daily session. And definitely, I think this would have given us lots of knowledge and wisdom. Today, this session is also going to be the same. So we have Mr. Pandya Raja, I think one of the well equipped wisdom is on having on the oil field, especially on the equipment manufacturer. To be say about, I think any of a brief introduction will be given from our yet the internship group. But he is the alumnus of Sriram Engineering College. I think many of our interns are been a Sriram College. I think he has your alumnus. Maybe I think he has said 2002 to 2006 batch. He has completed his BTech in chemical engineering. Definitely, I think you should be very proud that your own alumnus is coming and giving a session. And I think that's the proud moment. I think of the almost if you try to see the 15 years of their experience is going to be shared to you, and especially this is going to be an offshore. So you might be heard about, I think, onshore, I think, with our various eminent speaker, including Indian Oil Corporation, CPCL, and many more. I think today Pandya Raja sir is going to deliver, especially on the oil and gas industry, the brief history, because we should know why how this industry has origin, and what is the importance they created across the globe, and how the field has been equipped. If you any of the people we try to see, I think the topmost paid the field is oil and gas industry. Because if you see like a Shell or British Petroleum or Chevrolet, any company, they are the highly paid rather than IT or much more any industry they paid. So such a kind of the field we are there. Definitely, I think you people have the credit, and it will only take some period of time. Definitely after 5 or 10 years, I think you all will be sitting in the topmost priority. So without wasting much more time, I would like to invite our head, Dr. Subhashri ma'am, to give the introduction about our speaker so that we can initiate the session.
Good evening, sir.
Good
Good
evening.
evening, everyone. Mr. L. Pandya Raja, he is a chemical engineer with 14 years of experience in oil and gas industry and has navigated through multiple which include process engineer, system engineer, integration engineer, project engineer, field project technical leader, program manager, operations manager, and supply chain digital initiative specialist. He's learned the business operation model of upstream, midstream, and downstream oil and gas business with work experience in companies involved in EPC, OEM, and service business. He is experienced in managing multi-million dollar valued projects for esteemed oil and gas customers across the globe, which includes Shell, ENI, Petronas, Saipem, CPPE, PTT, etc. He started his career in technical role and straight to roles in management. Further, is currently working on business process and digital strategy on supply chain for oil and gas company. Sir, we are very much happy to have you here, and we request you to give your webinar on oil and gas industry, a brief history with introduction to oil field services and equipment manufacturers in OMG. Session is over to you, sir.
Thank you very much for the introduction and very nice welcome. Thanks for that. So let me go directly to the session. As Gogul sir has already told, you would have already, for any chemical engineer, oil and gas is one of the major domain that's going to provide any kind of job opportunities. So just to give you an insight, globally, the highest traded commodity, even as on today, since last 100 years, is just oil, nothing other than that. So as a chemical engineer, most of us will end up in the oil and gas industry, or you go to any other industry, right? For even in automobile industry, when a chemical engineer goes, he goes as a painting expert, or where you may go into the pharmaceutical industry because you will be involved into the process of the pharmaceutical chemicals. Still, every industry, it starts from oil and gas for the chemical engineer. So just to go into it, the important thing is before to go into the oil and gas industry, it will be more interested to know about the history of the oil and gas industry. Why history matters is, if you know the history, you can predict what will be the future of this industry. So just to say that oil and gas has been in usage for more years. Almost in 300 AD, it was used by Chinese to produce the salt from the seawater. They take the oil from the ground, they burn it, and they produce salt. So that's the oldest known historical usage of oil. The modern day usage starts in 1860s. Before to that, mostly the oils are taken as a seepages in the ground, or they used to dig the ground and try to take the oil to some minimum level that is never produced in mass. The modern era of oil started in 1860s. So in the 1860s, there's a Edwin Dark. He's the first person who was thinking, if we are able to drill and produce water, why cannot we drill and produce oil? So he drilled the first well in Pennsylvania, which was successful to produce the crude oil. That was the first mass possible production of crude oil ever in the history of the modern oil industry. But after the production, immediately the industry doesn't pick up. There are a lot of experts from the chemical domain started to evaluate it, and they come up to understand what can we do with this produced crude. So the industry picked up in 1870s. The first ever usage of oil is the replacement of whale oil. So in 1870s, there is no electricity. There is the fires are generated using the coal or dry woods. In 1870s, people came up to show that the kerosene that is producible from the crude oil can replace the whale oil. So by that period, the people used to fish whales, and they try to extract the oil from whale, and they try to use as a lamp for the lamp lighting. So by that time, they came as an alternative solution for the whale oil, because capturing whale became difficult because they have almost captured most of the whale available in the shale area. They have to go to the deep seas. So these industry came into picture by 1870s, and from then, from 19th century, 20th century, you name any billionaire, they have their business in oil industry. Everybody would have heard of John D. Rockefeller. He was the well-known billionaire who is, even today, if he is able to run his collaborated industry, he would be the billionaire. His family would be the billionaire family, but his industry has been, for the monopoly reason, they have segregated the company. But you would have heard of Noble, Alfred Noble, on behalf of whom we provide the Nobel Prize today. He also owned a big oil and gas industry in Russia. And the Rothschild family, which is known for a biggest banking family, also owned a big resource of oil in Europe. So you name any billionaire of 19th and 20th century, they have the business in oil industry. And as on today, you would have heard the stories that the oil price has collapsed. Maybe in the lockdown period, when we started, the oil has been traded in a negative rate, negative value, because US does not have a storage space. They have to dispose the oil. They are selling in negative value. And all these stuffs you would have heard. And all this dynamic news that you are hearing is not just we heard this time. It was historically common that these oil prices always dynamic due to different other reasons. So when we started oil industry as a lighting for the lamp in 1870s, it faced huge amount of dynamics because of overproduction. And at that time, Rothschild, the main person over that industry, John D. Rockefeller, tried to consolidate the industry and suppress the overproduction and try to control the price. It's normal in oil and gas industry. Every time this dynamics happen due to the overproduction. And in 1882, it happened to that Edison came up with the light bulb. So when Edison came up with the light bulb, the usage of oil was only to lamp, and people told that the oil industry is going to be died. There is nothing more than that. But eventually, before to the light bulb spread around the world, Henry Ford came up with the Model T car, which is eventually using the petrol as the fuel. And there was a good scientist who found the way to refine the higher valued petrol from the crude oil. So from then on, it's a rising consumption need of the oil. So every car that Henry Ford produced, and then Volkswagen came into picture, there's a lot of automobile industries. The car needed fuel, and the oil and gas industry has been keep on growing. And from then, it is always a saying that the oil is going to be dried out. and it was a saying every time, and it never happened till now. And we are keep on producing more than what we need as on today. That's the reason of price collapse. And after to that, in 1903, the Wright brother invented flight. Even that was running with the fuel. The consumption kept on increasing, and in the period before the World War One, Winston Churchill decided to convert all his ships that's running in coal into the crude oil run based ship, both war and logistic. His decision was basically thinking that German may come into war. We have to have a best logistic ship and warship, that so that we can demonstrate our capability in the sea area. So with that will, when he converted all the ships into crude, people realized that the handling of crude is much comfortable than handling the coal, and it is going to be much efficient to run an engine with crude than running with the coal. So from the coal based engine is nothing but a steam engine. So steam engine is not so better when we compare with the combustion engines. So that's how slowly people realize that oil is going to be more powerful tool than coal. When the World War started in 1914 to 1918, the war lasted for 4 years. Before to that, historically, there is no war that lasted for 4 years. It's just because of the reason that this is just not a war between human. It's a war between equipments, machines. So why I call that? By that time, there is a lot of automobiles and aviation already in the place. And when it is in the place, the wartime, every country is able to invest more to improve their equipment in automobile or aviation technology, by which they can try to suppress their opponent. Basically, just to give you one important note here, when in the initial date of wars, German tried to enter into the France, the French is able to deploy their military force quickly in the border just with the help of automobiles, cars. Before to that, if you have to wagon people from one place to another place very fast and the armaments, you need a train. The train runs with the coal, and you need to have a rail track already ready. And when the automobile is there in hand, they are able to deploy in a half a day because they can mobilize. They started to utilize the car of the private cars so that they can mobilize their soldiers to the border very fast. And this is where, like, for example, they started to build tankers, and with all these things can operate only if you have fuel. And there was one good story in the World War One, that one of the very well-known admiral of German was going ahead very far in the African region to capture the country, and he was going so far that he is the only person having the armaments and the fuel. He's able to run so far, and almost after a month, once his fuel is completely depleted, he has been defeated. So that's where the world started to look like, if you have to win the war, you need to have the fuel, so that you can mobilize your people, you can mobilize your armaments wherever you want, and you can fly, and you can be faster enough. So that's one of the reasons that World War One and World War Two lasted so longer period, because it's a war of machines, not a war of human. And this war of machines at that period proved that without fuel, no countries can win. And even in the World War Two, when Germans has been failed, just before their failure, they were trying to mobilize their warfare to the Poland region. They were moving, and just a kilometer before they reach one of the big storage area in the Poland, they have been failed miserably. If at all they have reached that storage tank area, they would have a fuel to fight for another 5 days. A 5 days of extra fight means something different than what has happened in the history. So the countries almost realized that without fuel, you can never win the world. You can never have your power stabilized. So that's where countries, like after the World War One, the oil is not just a commodity of common man; it's a commodity of political. That's where, like, US had formed the Energy Commission, and in every country they formed the Energy Commission. That's why you see most of the companies that produce oil or that refines oil are part of government organization. Government wanted to have control on their fuel availability, and the fuel availability means the mobilization of people the mobilization of armaments or mobilization of food or whatever you want. Without that, nothing is going to move. So that's why government started to control it. And that's where it happens that oil is just not a commodity of common man, it's a commodity of government, and it's a commodity of geopolitical issues. So today, as on today's world, whatever you consume has some part of oil in it. If you had food today morning, it it has mobilized from one place to another place. Somewhere it has used the oil. And if you had a cloth weared, it has some polyester or whatever it is. It has a oven machine, whatever it is, has used by one or other way the the oil. If you have a computer today, it has a plastic, silicon chips or whatever you have in it have something to do with oil. So oil is a basic commodity that is everywhere, and you don't have a world without oil as on today, and I don't see it even in near future until unless you find an alternate. The alternate is not just a fuel or just energy. There is more than that. So when we say in terms of production economy, globally, oil is the highest traded commodity. And you would have heard like Brent oil, North Sea oil, or WTI, Bombay High oil. So all these are different grades of oil. Why they call it grade? Oil produced in different ground is of different quality. None of them is of same quality. So that's why they usually call oil with a grade. So when we say Brent blend, it comes from US. When you say Nazi field, it comes from UK. When you say WTI, it's a West Texas. It comes from US. So it's like uh, each country has its own oil field. Each oil field produces a unique oil, and each of this oil right now we extract them, we refine them, and convert it to the specified quality of our need and utilize them for our regular purposes. So just to give a brief idea of how this oil and gas industry exists, they usually call it as three streams of oil and gas industry: upstream, midstream, and downstream. So upstream, what's upstream actually? Upstream is you have to search for oil, that is oil exploration. Once you find it, you have to produce the oil. Produce the oil means the oil is in the ground, you have to dig it and take it out, that's oil production. And in the upstream section, there is a division called oil field services that provide services for the people who try to find oil and take it out of the ground. And this upstream section can locate on the ground or in the sea itself. So you may find the oil on the subsurface of sea or on the ground. So that's onshore or offshore. And the midstream is the oil transportation technology. So LNG is a liquefied natural gas. You have a natural gas, you liquefy it and you transport it, because natural gas, once it is liquefied, you can transport it very easily, the highest volume of gas. And then the pipeline, you will have a inter-country pipelines, the pipeline that runs for thousands and thousands of kilometers across the country to transport the gas produced as one place to another place. And today, people call the oil and gas industry in trouble. Just to give you a brief introduction, the trouble is majorly in the upstream division, not in the downstream division or in the midstream division. Even in this lockdown period, globally, we had two LNG projects that has been kickstarted. So what it means, that the demand for LNG already there in the market. Companies forecast it and they are able to invest billions of dollars in that. And in this list, LNG is one of the very expensive projects. And so they are starting the LNG project in this lockdown. So you can consider that industry in upstream is producing higher, but in downstream we had lot of way to go ahead. And in the downstream side, the refining is something, you get a crude oil, you convert into petrol, diesel, or aviation fuel, or a specialty chemical, whatever is done in the refinery. And the petrochemical, it gets the product from the refinery and convert it into the specialty chemicals. And the fertilizer industry, of course, that's also based of the oil industry. So when I say oil industry, I told you about brief segregation of industry. And now you have to also know, in this segregation, usually any industry globally can be segregated into three categories. A company can be a product-based company. What it means, a company has a specified technology-based product and it is supplying the product. And a company can be a project-based company. What is meant by project? A project has a unique start and a unique end. and the project is not a repetitive task. For example, if you construct a house, it's a project, or if you construct an office, or if you construct a factory, it's a project. So the oil and gas companies can be a project-based company and a service-based company. What is service-based company? Is a companies those help for the regular operations. So if you have to operate something, you have to keep on servicing something. So when you have to do the service, you may have to have a services company in your help there. So any company that can be a product-based company, project-based company, or service-based company. So for example, when we say oil producer, who is producing oil from the ground, that's a production-based company. They are producing the oil and they are selling it. And exploration and drilling services, somebody who is trying to search for the oil and trying to drill it and give it to somebody else who can produce. For example, in the oil producers category, in India, we have GAIL. GAIL is a producer, and Kane Energy, they are the oil producer. And then when we call as exploration and production, we have a company like Aban Offshores. What they does is they just Aban Offshore. If you say in slang language, it is kind of a borewell company. So they have a borewell machine, they drill and produce. They drill and provide you the final thing. Maybe borewell company is kind of oil drilling is not simple as water drilling, but it is similar somewhat. So the company which search for oil and drill it are the project-based company. They may do services and service delivery as well, because once you drill and produce the oil, the drilling help doesn't end there. After to that, if something struck in, they have to come back to help you. So they may do project and also service delivery. The oil field services, that is one of the division that we are going to talk about today. So the oil field services is a section of business that provide the technology for both oil producers and the exploration and drilling companies. So they both deliver the product and also services as well. And then there is another section of business that is EPC, engineering, procurement, and construction. They are project-based company. If you have to construct a factory or any facility, you may need an engineering, procurement, and construction company that will do engineering for you, that will procure a material on behalf of you, and that will construct on behalf of you, and they will deliver a project on behalf of you. And then equipment manufacturer. So you cannot construct everything by yourself. For example, if you have a home, if you have to have a motor, you will not construct a motor by yourself. You have to go to the equipment manufacturer. For every specialty equipment, you may have a licensing or you may have a technology involved in it, and there may be a specialty manufacturer who will do it. Those are equipment manufacturer. The equipment manufacturer owns the product and they do a project and service delivery as well. And then the refiner. Refiner is a production-based company. They get a crude oil, they refine it, and they produce a petrol, diesel, or any kind of tar or whatever is needed. They produce it. They are a production company, and the petrochemical is kind of production company. Fertilizer is also a production company. LNG is also a production company. And oil transportation is a service delivery. And there are a lot of marketing and distribution agencies as well. Those are service delivery kind of operation. So this is a broader perspective of business. Any business, not only oil and gas, wherever you go, a company may be a product-based company or a project-based company or a service-based company. For example, if you take automobile industry, Maruti is a product and service-based company. They have a car as a product and they do services for your car once they sold it to you. And they may do projects if they construct a new factory. That's how it is. So let's go into the oil field services. When I say oil field services, globally, there is 3 big players in this business: Schlumberger, Baker Hughes, and Halliburton. Every time when you hear that somebody from IIT is getting package in crore, it is mostly Schlumberger. So this is the company that pay in hefty, and maybe they employ people in some unknown region like the borders of the earth, Arctica or Antarctica, wherever there's a drilling happens, they go there. So what does this oil field service company do? They are the owner of technology. If you want to explore and drill, for example, you have a borewell service guy who drill on behalf of you. Did that mean he manufactured the drill bit? Did that mean he manufactured the motor that drilled the well? No, he has to buy it from somebody else. Similar to that, if you have to drill a well, right from the drill bit, motors or pumps or whatever is needed to make the well completed and happen to produce, it comes from the oil field services company. And they also provided technology consultation to any kind of manufacturer that want to produce the oil. So before to go, on what kind of product they do, we should also be aware of how the oil is produced. So everybody would have heard of the story. Oil came from the fossil fuel. Maybe a dinosaur has dead and stuck inside the ground and has been converted into oil. It's something similar. Any organic matter that has been buried in the surface that get decomposed and slowly get converted into the oil. So when we say slowly get converted into oil, like they call a range. Asan today, we have never drilled the ground below 13 kilometers. Below 13 kilometers, whatever see in our book, it's just what we see in our book as per our knowledge of whatever we can do with seismograph or whatever we can assume or whatever we can postulate. The real thing, we have drilled our ground just 13-kilometer strike depth. I mean to say strike depth. So for example, for the oil, when you drill 2 to 4 kilometer, you may see oil in the surface. And when you drill 3 to 6 kilometer, you may see gas, because it is basically based on the temperature range. So when you go for 2 to 4 kilometers, you may have a temperature range of 60 to 120 degrees centigrade, where oil may exist as oil. It may decompose to the oil level and it will exist as oil. And when you go still deeper, the temperature may slightly go up and you may have it in the gas form. And when you go further deep beyond 10 kilometer, mostly the hydrocarbon is going to get destroyed because of the temperature ranges. So it's like any organic material, whatever you have, will get converted into kerogen. The kerogen is slowly decomposed and get converted into oil. And based on the temperature range or still further decomposition, the oil may get converted into gas. That's how it exists. So Asan today, most of the drilling that happens up to maximum of 13 kilometer as a straight depth. They may say we have drilled 25 kilometer, 50 kilometer. If you see, it is not a straight depth. Maybe they'll drill straight depth of 5 kilometers and they may go the horizontal depth of maybe a number of kilometers, whatever that is needed. So how the oil is present inside the ground, how you are able to take it out. When you say oil, you need to have 4 things. Only if these 4 things exist, there is a possibility of oil. They call it a trap. Trap is something it's really a trap. So you need to have an impermeable layer. You see here, right? An impermeable layer. And so just a moment. So you need to have this impermeable layer. Impermeable layer is something you can assume a clay. So if you have a clay and if you pour water in it, it will not move to the other side. So that's an impermeable layer. And then you need to have a permeable layer of material. So this permeable layer, you can assume a coarse sand. And then you need to have a source rock. So what's that? The source rock is something that's an organic matter that is going to get converted into oil. Then you need to have a reservoir rock. The reservoir rock is nothing but a porous material, a sand or those kind of stuff, which can hold oil or water like a sponge. And then you need to have a seal. The seal is nothing but an impermeable layer. So the impermeable layer should close the oil or gas formed as a 3-dimensional closure. So it should be like this. Maybe you need to have a seal like this, and you need to have a possibility of oil or something has been getting stagnated over here inside the permeable layer. Then only there is a possibility of oil presence. The oil can be present in any form, like different kind of ways. The thing is, if you have to explore the oil, you have to find the subsurface presence of trap, the 3-dimensional closure, and the porous material that can hold the oil, and the source rock that can produce the oil. The source rock is nothing but the organic material that has been get stuck inside the ground. And how well the ground will produce oil, it depends on the porosity of the reservoir rock. So the porosity is like it's a sponge kind of stuff. So how much spongy it is, that much oil it can hold, that much we can extract out. And permeability is a kind of factor that can how much the oil can be let out by that sponge. So with all these things, if there is a hydrocarbon accumulation, we can extract it. So how they used to find it? Basically, in the olden days, in 1860s or 1870s, when they first drill, they tried to find the seepage. Because of the presence of oil trap that that is already filled out and the oil is going to get leaked out, it may seep out to the floor. When it seep out to the floor, people will try to dig around that area and try to find if there's a oil that is going to be present. That's how the olden day it started. But now, how the people do? Now people use the seismograph. You would have seen the Jurassic Park. They would have gone and drop a big bomb and they put a seismic sensor all around the area to see how the vibration is happening. Based on that, they will understand what is there in the ground. That's what the seismic appreciation or seismograph is done in that way. So what we do, we try to make the vibration in the floor and we try to see how the reflection happening. Based on that, we try to plot how our subsurface is present. When we know and when we plotted how our subsurface is present, we may be able to understand the level, like the porosity of the material, the presence of trap around the material. And if you know there is already oil somewhere in the nearby area, seepage you found, or if you found somebody has drilled and found the oil, for sure it's a potential area to explore and drill. That's how they do the exploration. And oil exploration is always a luck-based parameter. People try to search. If they strike, it's a big hit. If they doesn't strike, they have to keep on scouting. And while scouting, they use different methods like this. So when you say you have to search the oil with seismograph and then drill, how the project works usually? First is exploration. You have to go around, you have to search, you have to find a potential area, and then you have to do appraisal drilling. So you drill one well, try to understand if something is present there or not, and you drill it. And if you are able to find some resource, then you may do a further evaluation on the area, that this area is a potential place. And in that, if you find there is a justifiable amount of oil resource where you can invest the equipment to produce that oil out of the ground, then you make the further developments on the commercially viable area. What you do as a development, you start to drill multiple wells. You start to complete the well. When you say complete the well, you have to put all the pipings, you have to put the pumping inside if you need. If you have already a pressure, the oil will come out automatically. All these things you have to do the engineering, and you have to buy all the equipment required, and you have to complete the well, and then you have to start producing the oil. And after producing the oil, for sure the pressure is going to get down or something is going to happen. So you have to continuously regenerate it. Like you have to enhance oil recovery by heating them or by doing a chemical injection, or different other technologies are available. This is how normally the oil field works. So in these, how the drilling happens. So you would have seen these kind of drilling machines. Maybe it is something similar to what you see already in the water drilling equipment. There is a hoisting system, but there are a lot of safety items that is completely different from the what you call the normal water driller. What are the safety items? For example, let me say you. So you have a hoisting system. This hoisting system will connect each pipes line by line and try to push it to the ground. And nowadays there is multiple technology. You may have motor on the surface that drive the shaft, or you may have motor underground itself. Motor is fixed here. This motor rotates, and also you can turn the direction of drill bit to any direction where the drilling can happen horizontally. It can drill horizontally, vertically, any kind of direction you can drill. Maybe sometimes people, you may see just one hole in the top, but when you go underneath, they would have segregated into different lines. That's all possible in today's world. And then they will have a circulation system. What is this? They will have a special mud. If you see the water driller, he may continuously inject the water while he is drilling because he just wanted to cool the drill bit. But here it is different. You have to cool the drill bit. Also, you have to realize that if there is a oil in the ground, it is going to push out into the floor and can create a haphazard situation. So what they do, they usually inject the mud, and the mud with very heavy density in such a way that this mud will hold the oil even if we strike the oil. And then they will have a rotating system that can be a special motor near the bit or on the surface itself. And you may need a motion compensation system in case if you are on the drill ship. You have to assume a technology that you are in the ship and you are drilling the floor like this with the shaft that is metal. And in that case, they have a motion compensation system where the ship may rotate, but it will never move out of the position where the pipe or something is going to break out. And for sure, the very important safety equipment here is the blowout preventer. This equipment is kind of, when you drill, all of the sudden you strike the gas and it is going to explode out and it is going to create a fire. Immediately there will be a shear ram here. This ram will cut the pipe that drilled the hole and close the well, just to safeguard the surrounding. So this is just one of the simple example I provided, but if you go deep, you will see a lot of different other equipments over here. So what they do as a oil field services. Oil field services company provides the drill bit, the motors, and like the drilling fluids. So the drilling fluids, what I told you, is a special technology. For each well, you have to have special density of the mud. And for each well, you have to maintain the different kind of chemical composition in the mud. That's a big study people used to do. And they used to design the muds for that. That's a mud design team. And then there is a chemicals. For example, once you drill the well, you put a pipe, you are taking a crude oil in it. Normally, if you see in your house pipe, if you regularly use a bore water, you could see the pipe is getting clogged very often due to the deposit of salt. Here you are producing a crude. You have to assume a lot of things like aspartate, sulfates, whatever is there that can get clog the pipe. Usually they use different kind of chemicals to inhibit this kind of stuffs. And there's another group that's called as completions. What they do is like kind of, when you drill the well, after drilling, you have to have different kind of equipments to produce the oil out. For example, the after drilling, the soil should not fall in back to the ground, fall in back and close the well. So you need to have a piping, and in the lower level you cannot have a full piping. You need to have a special filtered arrangement that will send only the oil. If there is a mixture of oil and water, there are some special kind of completion equipments that will allow only oil, stopping the water based on the density difference. So those kind of equipments are coming from the completion groups. And then they will have artificial lifting. Maybe you would have seen a donkey head kind of stuff. Or if you have any submersible pump that has to go below the earth and that has to run and pull the oil to the ground, that will be done by the artificial lift team. And then the wireline team, it's like when you are drilling the well, after drilling, you have to continuously understand what is surrounding. So in the wireline, you will put a lot of sensors and you will insert that wire below the ground to see what is present. And even after drilling, if something is like many sites has happened, like while you are drilling, the drill bit will break and strike there. In this case, you have to put a wireline equipment to fish it out. So those kind of equipments are special. These devices are done by this kind of oil field services company. So they are also involved in geoscience. Geoscience is like kind of understanding what is on the subsurface, the seismic equipments, and they'll have a lot of group of geoscientific people who will be doing a technology services for the company that is going to drill on the floor. So the oil field services company will not drill directly. For example, Baker Hughes may give a contract to Aban Offshore. Aban Offshore will drill the surface, but all the equipments, right from the drill bits, the drilling fluids or chemicals, whatever is needed to do the activity, will come from the oil field services company. So that's what the oil field services company does. And most of the product they usually give in rental services. For example, many companies buy the drill bit for rent. They don't buy it because those are very expensive bits. Sometimes we have a drill bit that have a diamond, the real diamond in it. Why you need a real diamond? Diamond is the very hard cutter for the rocks. So those kind of stuffs, nobody can buy it for their own. So mostly they buy it for rent. And this kind of company provided for rental services. Mostly all the drilling equipments are provided for rental services, and the completion equipment that has to be kept inside the well, or artificial lift equipment that has to be kept inside the well, are sold as a product. So how do they supply? So this is all about the oil field equipments. So next we can go to the original equipment manufacturers. So anyway, oil field equipment is also an OEM company. They manufacture a lot of equipment like pumps, motors, and they manufacture the drill bits. They manufacture the drilling muds, those kind of stuff. And here, again, we are going to specifically talk about the original equipment manufacturer. So what are these companies? For example, if you are going to put up a fertilizer plant, For a fertilizer plant, you need a compressors, you need a gas turbines, you need a lot of fractioning columns, you need a lot of special equipments, motors, pumps, whatever it is. All these equipments are not manufactured by any engineering, procurement, and construction company. It is all it is all manufactured by the OEMs, original equipment manufacturer. So these manufacture, like you will have for each product the own different manufacturer. For example, when you say motors, ABB is one of the specialists. When you say gas turbine, GE or Siemens is the specialist. When you say compressors, Nuopignane or Rolls-Royce is a specialist. So those kind of every equipment, there is a special vendors who owns the technology, because it is just not a customizable engineering at every time. These are the product based companies. So what this original equipment manufacturer do, they have their own manufacturing facility and assembly facility. They have their own technology based product, and they manufacture based on the order that comes from the engineering company that is constructing the manufacturing plant. So example of original equipments are like compressors, gas turbines, steam turbine, valves. So in each line, each item is a core technology based product. For example, just to say you, gas turbines, nobody buy a gas turbine that does not have a proven lifetime. So for example, if I have to sell a gas turbine in a market, I have to have a history of running hours. And if you are going with a new product, the market won't absorb it very easily until unless you have a higher experience in doing that. Those are kind of special technology based products. Similar to the car, Shift is always expensive because on that size of range, it's because it's a proven car. So something like that. So each product over here is a core technology that is owned by that special manufacturer. And this, most of the time it happens like they manufacture the product, they deliver to the customer, maybe the engineering company that is constructing the manufacturing facility. After the delivery of product, the end user who is running the manufacturing facility or production facility has to contact again these vendors to do the services. For example, if you have a gas turbine, you bought it through, like GE is building a gas turbine and compressor, and it is giving to Saipem, which is the EPC company, and the Saipem may buy it from GE and assemble it in their equipments and make a final manufacturing facility and hand it over to let us say Indian Oil. Indian Oil is going to produce the oil or whatever is through that factory. During the course of operation, Indian Oil is supposed to again contact GE, who is the equipment supplier, to do any replacement of spare parts or whatever it is, because all those spare parts are specialized equipment. So that's where the OEM comes into picture. So how these OEM operate? Usually these kind of big OEMs, I would say big OEMs because there are a lot of small OEMs like the ABB, those kind of thing. They manufacture the motors. Those are kind of, they manufacture only the product. They don't customize anything for the customer needs. But there are very big OEMs like GE or Baker Hughes. They customize, they have a product, they have product with the technology, but they customize it based on the customer need. So what they will have? They will have a product based division. What this division do? They find what is needed for the market. For example, gas turbine, they have 50 megawatt turbine. Right now, there is a demand for 55 megawatt. Maybe we have to do something in this machine. That's what they do first as a market survey. And then they initiate a project for that. And then they do the improvement on that product. And before to transfer it to the project organization, they make sure that they are testing it well. And then they transfer to the project-based team. What this project-based team do? They talk to the customer to understand if there is any additional customization. When I say additional customization, they will not touch the product, but they will do something surrounding the product. Like for example, if you have a gas turbine, it will remain as it is. But for the gas turbine, you will have a lubricating system. You can build it in carbon steel or stainless steel based on the customer need. So those kind of customization are done by the project-based group. So, and then at the project-based group will have a sales team, the project management team, and they will do a site installation activities. And the product-based team is not a revenue team; it's an investment team. Like The business has to find what kind of technology they have to invent, and they have to give money to the product-based team. The product-based team will develop the product, and the project-based team will sell the product to the customer. Those are revenue-based business section. And then there is high margin business for this kind of OEMs is the service-based model. Once you sold the equipment, you and your customer are married. So for the full life of equipment, they will pay you for the services. So that's how it works. For example, if you buy a Maruti car, it is not just one-time investment for you. You may buy it from a reseller, like a showroom you will buy it from. Maybe the showroom is just a seller. Once you buy it, you may go to any Maruti service center and you will keep on doing a service till you own the car. That's how it works for the OEM. So basically, in oil and gas industry, the OEM and the oil field equipment engineering companies are in some way highly paid. So I would say all the OEMs are not highly paid. Like for example, the oil field equipment is also an OEM company. They are highly paid. And on terms of companies like specialty equipment, like the gas turbines, or the companies that manufacture the licensed product, like if they make a fractioning column, Holotopsy is a company that make a special licensed products. So if they make some licensed product, those companies usually pay higher because they have a technology as owning. So what makes the difference? They does not sell the metal, they sell the licensing and technology. That's where the cost comes in. If you are in a company that is selling technology, that is going to pay you hefty. So that's how it works. If you are in a company that is going to sell a metal, like if you have to work for a company that is just making a piping assembly, their margin is going to be lower because anybody can do it. But if you are in a company that is selling a product that is highly technology oriented, just like that, nobody can manufacture a gas turbine, but just like that, anybody can manufacture a lube oil console. So that's how it differs. So when I say projects or products, every group of company, and usually when you look for a job, you will look like any chemical engineer can fit into sales very well, project execution and manufacturing, site installation and commissioning and startup. And they can in all the streams of projects or product flow, chemical engineer can fit in. So in terms of sales, most of the time your customer is the oil and gas company. So you will be end up discussing with the process engineer to convince them which kind of model, machines, or whatever thing they have to choose. So right from the sales, on terms of projects execution, planning and management, and manufacturing. Manufacturing, I mean to say, there is a lot of, for example, OFE business that has a lot of specialty chemical manufacturing divisions where they involve chemical engineers. And in terms of site installation and commissioning startup, for any kind of oil field equipments or the specialty equipments for oil industry that need a chemical engineer to understand the dynamics. And in terms of warranty period, there will be a lot of minor issues comes up. In terms of think in the broader perspective, there will be involvement. And in terms of service contracts, like for example, you will have a warranty, after warranty it will be a service, and then the spare parts. So that's how in all the sections there will be involvement of chemical engineers. So what are the roles chemical engineer usually take is they will be doing engineering design activities, site activities, commissioning activities. So engineering design you may do both as a part of project execution, also as a part of sales executions. And you may do a simulation and analysis, or the project engineering and management, or the product engineering and management. And you may do it in any product development, like you do a product development section or a project management section or a sales section. In all the section, all these kind of activities are common for chemical engineers. So this is for OFS. When you call oil field services, majorly the chemical engineers are involved in selection of specialty chemicals. For example, when you say the oil field wells, there will be a lot of corrosions or asbestos or biocide, those kind of things has to be utilized. So you have to analyze the crude to understand what kind of crude it is, which kind of stuffs are present over there, and in that case you may have to use some special inhibitors. Those kind of stuffs are designed and developed by the chemical engineer. and the mud engineering, as I told you earlier. And for example, if you have a well, if it is producing this much, and this is the well seismographic design, how much it can produce in long run, that's the flow assurance. That study also will involve the chemical engineer, and chemical engineer will involve in any product design and developments for all kind of equipment. And in terms of supply chain, if you have to do any kind of special chemical supply chain activities, buying a chemical or qualifying a supplier for supplying a chemical, the chemical engineer will be there as a part of it. So I think I have given you some brief idea, I hope. If you have any questions, I'll try to address them possibly. I don't know if I have not bored you.
Yes, sir. Thank you so much. I think you've given a very deep knowledge on this, especially on this equipment and the manufacturer. Definitely, I think all the students are the final year, so maybe I think it will be very much useful for them because they're going to step inside the next level of a career. So with that, I think the students can have any QA. I think you can unmute or you can even put it in the chat box.
Hello, sir. Can you hear me? Am I audible or?
No, yeah. I think so. Quite you can. Who is speaking?
Babin. My video
Babin, I think. Yeah, fine. You can keep your mic nearby. Your voice is quite low.
Sir, now it's audible.
Yeah, fine. I think.
Yeah. I am having 3 doubts, sir.
Yeah.
So at starting, you said that people in voltages, they were using whale oil to light up lamps. Why they stopped after that? After voltages, why they stopped extracting whale oil, etc.
Can you repeat the question? Maybe I missed it.
You said that in voltages, people were taking whale oil. Why they stopped taking whale oil after that?
So whale oil was expensive compared to crude. So for example, whale oil is something fisherman has to go to the deep seas and take this fish, and then they have to kill the whales and they have to produce the oil. By that time, when the crude oil come into picture, it was much cheaper alternative.
Yeah, okay, sir. So the next doubt was, you have said 4 to 6 kilometers needed to take gas.
Yeah.
But how the machines will extract, how the machines will take gas from the deeper, and how they will extract the gas? In what form you will get?
Usually when you have a gas will have its own pressure. So for example, when you evaluate the well, they will try to drill in a place where they are going to take the oil first. Maybe they'll take the gas as the next level, because the gas is the one that is going to manage the pressure inside the well, and it can push the oil to the surface. That's how they usually design. And if unfortunately, if you take the gas first, then you have to put the pump below and you have to pump up the oil. So basically, gas does not need anything to come above. But the oil, if there's a gas pressure, the oil may come above with the pressure of the gas. If there is no gas, you may have to put the pump in the ground and you have to use that pump.
Sir, the pump will be steel pump because it has 100 to 200 degrees Celsius heat under the earth.
Yeah, we have special pumps. That's where the technology comes in. That's why the oil field equipment guys are able to pay that hefty. They have special electronics and the special devices that is able to operate in that rigorous condition. And just to give you some insight, for example, if you choose a wrong material, one of the well in our India that corroded the pump in just 1 week. If you choose the wrong material, it can corrode a pump in 1 week. That's how it is, rigorous it is. Maybe people put a lot of efforts to find the right material choice, and they may have to do a lot of chemical flushing so that the corrosion doesn't happen inside.
Yeah, okay, sir. So another doubt was, in oil and gas industry, that machines will play a major role, sir. Inside workers, what they will do, you have said that mud engineering and that many engineers were there. They will have a little bit work to search for them. What will be the major role for workers inside there?
So in terms of chemical engineers, you mean to ask, right?
Yeah. Yes.
So for example, when I say
oil and gas industry, chemical engineers only will play the major role. So that I'm asking, sir.
Yeah. For example, when you say mud, thing is, we are not using the same mud historically.
Oh,
It is
okay, sir.
evolving, right? So where we are involved in R&D, the major stuff is R&D, and once the R&D is there, you will design the mud, and for every
Yeah.
well the mud requirement is different. That is the requisition. Requisition is kind of one who is selling to customer is also a chemical engineer. He will
Yeah,
talk to the
okay.
customer and sell the product. And once the product is sold, one who is designing for that specific well is also a chemical engineer. There will be one more person who will be involved in R&D to find special chemicals that can change the density of the mud in different ways. So that's how it is everywhere. Those are the kind of highly paid role, the R&D
Yeah.
roles and the role that are in
Oh,
sales.
okay, sir. Yeah, very much thank you for explaining this, sir. Thank you, sir.
Yeah, thank you, Bhavin. Is
Sir,
there anybody? Yeah, Shekhar.
good evening, sir. I have a doubt regarding the technology consultation. You were saying that when you were explaining about the oil field services, you were saying that they will also give technology consultation. So, what kind of technology consultation do they provide?
Okay, so for example, the geo services is a kind of one major technology consultation. If you have to find an oil in some places, globally, you have to do a satellite mapping first. As on today, in the today's technology, they do a satellite mapping and they do a complete seismographic analysis. And all these things need a lot of geoscientist involvement. The companies like Baker Hughes and Schlumberger have a group of geoscientists that can do that activities for the production company. For example, Gale is an oil production company. They may not have that kind of technology, that kind of people involved. So they cannot these people work across the globe with different companies. So they have a different kind of exposure. That's how the technology consultation happens in geoscience. And for example, let us come to the simpler example, come to the drill bit. So if somebody has to do a drilling, they may go to a company like Aban Offshore. Maybe Gale will go to the Aban Offshore and ask for the drilling. And Aban Offshore, do you think they can select the drill bit? They need to know what is in the ground. They cannot just use a simple steel bit to drill the rock. That may not go out. They need one person from the drill bit manufacturing team or from the drill bit engineering side to tell this is the subsurface prediction by the geoscientist, and as per this you may have this kind of maybe coarse material and this rock up to 1 kilometer you use this bit. That may be a simpler one, and after to that you use this bit. So these are kind of consulting effort. I'm saying it in a simple language, but
Yes,
this involves a lot of efforts to put the right material in place. That's where the consultation comes in.
sir, I'm having another question also.
Mhm.
So, like when you were explaining about the product-based companies, project-based companies, and service-based companies, in these sectors, which sector does freshers get recruited?
Which sector has?
Which sector, from which sector, like the freshers are getting recruited? Which sector?
Asan today. At Asan today.
Yeah.
Okay.
Yeah.
So in the today's scenario, Asan today, after lockdown, I see some good improvement in the LNG market. So when I say LNG market, almost everybody is involved. So EPC companies are involved, and the equipment manufacturer are also involved. So only major struggle is faced by the oil field services company because of the overproduction. They have stopped most of the drilling activities. So but when you come to the downstream side, the LNG based industries like the EPC companies or equipment manufacturer or the LNG companies itself, they are having some good amount of jobs. They should be hiring. Any other question?
Yes, sir. That's a. Thank you, sir. Thank you for sharing your knowledge.
Thank you.
Sir?
Yeah.
Sir?
Yeah.
Sir, I have one question, sir.
Yeah.
Does crude oil viscosity vary with depth, sir, within the same oil formation in drilling formation, sir? Sir, now clear, sir?
Your voice is a bit
Sir?
breaking.
Now
Yeah,
okay, sir.
Now okay. Yeah.
Sir, how does crude oil viscosity vary with depth, sir, within the same oil formation?
Okay, within the same oil formation, you may find a same kind of character. Mostly, there can be minor difference. Like for example, if you drill in one place and if you go and drill after another a kilometer, and there's a possibility that you have minor differences. It is not just viscosity. There are a lot of other parameters, right? From the kind of chemical present in the crude itself can be different.
Okay, sir. Thank you so much, sir.
Yeah, I think we have a few more questions from the chat box also, sir. Maybe one is from Mangesh. How the engineers are determined the crude oil in underground? Are they use any specialized sensors?
Okay, let me see if I can see the chat. Okay. So, which question it is?
That's the first, I think. Like if you like come down, I think Magesh R has asked.
Okay, how engineers are determine the crude oil in the underground? Are they use? Yes, they use the seismic sensor. So what they do, basically, to produce the oil, you need a trap. What is trap? You need to have an impermeable layer, kind of clay, that is surrounding three sides, that is going to hold the oil, and then you have to have a permeable material, kind of a coarse sand kind of stuff, and then you need to have a organic material. So all these things they try to predict it with the help of seismograph. Seismograph is something that they try to vibrate the floor, and they try to see how the vibration resonates on the surface. Based on that, they'll predict how the underground is there, and they'll map it out. And then it's just a prediction. You cannot be 100% sure before you drill. Is that clear?
Yes, sir. You can unmute it. Otherwise, we can go ahead with. Yeah.
Sir, I have a doubt. Like every other industries, oil and gas industry is also making use of water for drilling and hydraulic fracture and for removing the drilling bits. And the water that is obtained after all these processes is highly viscous. So are the companies reusing this water, or how are they treating this?
So, okay, you mean to say about the drilling mud, right?
Yes, sir.
Drilling mud is usually expensive, so they reuse it. After every drilling, they try to collect it back and they reuse it, but still there are something that are left as landfills. It's not, the oil and gas industry is not a completely green industry, but we have to understand that this is the only source as on today we have.
Okay. And one more question, sir.
Yeah.
Recently, Shell has discovered this monodiameter well technology. So what is the principle behind that, and what is the material that's being used for the liners?
Okay, monodiameter you mean to say, right?
Yeah, yes, sir.
So what they do is they will have a single hole in the surface. If you see in the surface, you will see only one well and only one Christmas tree on the surface. But when you go underneath, you will have, like, you can have almost 10 to 20 or even 50 kind of branches. So because they have a directional drilling, with that they do it.
Okay.
Thank you. I think we have two more questions in our chat box, sir.
Okay, what is the
One
specific
is
major role?
Moinuddin. Yeah, what is specific and major role for chemical engineers upstream companies?
Okay, so when I say upstream company, the upstream companies are so oil field equipments and the oil field services companies are majorly dominated by mechanical engineers. Just to be very frank, that's normal because those are the product design and the completely product based companies, and there will be very few chemical engineers on the chemical section and also on understanding the well dynamics. The major domination of chemical engineers are in the downstream section, where it plays like refinery or kind of fertilizer. Those kind of industry needs a lot of chemical engineer compared to the upstream companies. Okay. What if the Tesla car get into use? What will be the...
Sir, I have one question, sir.
Yeah.
Sir, as you said, coal, major than coal, crude oil is more to use produce electricity, generate electricity. In, by future, there is a demand on crude oil, sir. Instead of crude oil, we use coal. In coal, the graphite is present, sir. By using graphite, there is a we produce graphene, sir. The final state of graphite is graphene, sir. By using graphene, there is a major purpose to produce electricity in every field, sir. What's your opinion, sir?
So, okay, technology wise, there is a lot of possibilities. I will not say oil is the only possibility. So, for example, I would give you one historical instance. Like while oil becoming a predominant usage in the automobile, like when Henry Ford started to use fuel oil, all this kind of stuff, there was at that time there was one alternative that were coming up at that time itself is a coal oil. They convert the coal into oil, and even you would have heard of Hitler has heavily invested in that technology because German has a higher coal presence than the oil. German does not have oil. That's one of the biggest reason they failed all the wars. So he was highly invested and investing in that technology to produce the synthetic oil from the coal. But still, what happened is Rockefeller won the war by investing and spreading the consumption of oil much faster than the coal. So it is not just a matter of technology; it's a matter of business.
Okay, sir.
You understood what I mean to say?
Okay,
so,
sir. Okay, sir.
For example, at that time, to promote the oil and gas industry, Rockefeller sponsored pharmaceutical industry to use oil-based chemicals for the pharmacies. So even today, most of the pharmacy chemicals comes from the crude. So that's how it is. It is technology is present everywhere. Even today, I see one more message like if Tesla is able to produce the electric car, yeah, Tesla is a business company, and if at all they will be able to market more electric cars, and if at all they are able to produce more green energy, for sure, the consumption of crude can get reduced. But it doesn't mean that you can replace everything. For sure, Tesla is going to have a tire that's going to need a synthetic
Okay,
rubber.
sir.
Maybe you will reduce the consumption. For sure, you will not.
Yes, sir. The India also bought crude oil from other countries. Till nowadays, only we use crude oil in our to generate electricity, sir.
Yeah, electricity. Nowadays, the major forecast of electricity is going on in the side of LNG. That's why LNG is booming. So most of the countries just to show them they are reducing the carbon, they are moving from coal-based power plant to the LNG-based power plant.
Yes, sir. Yes, sir. Okay, sir. Thank you, sir.
Thank you.
Thank you, Sundar. Yeah, sir. I think two more questions are there in our chat box.
Yeah. How found the leakage in pipeline? They said any sensor in the pipe or specific team to find leakages. So you mean to say the leakage in the well pipe? Am I right, Prashant?
Maybe Prashant,
yes,
you
sir.
can.
Yes, sir.
So okay, so this well pipe, it's like underneath the ground it cannot leak. What it's going to leak? Because underneath the ground to some level they put a pipe, and surrounding the pipe they put a concrete, and below that there will be a liner hangers. Hangers is kind of the pipe that is going to hang, and even if it's leak, it's going to go into the ground itself. And if it is going to leak in the surface, for sure that is a problem. They will have a Christmas tree. Surrounding the Christmas tree, they will have a lot of monitoring systems. So underground, majorly, they will have some safety devices. Like for example, you have a well, they call it a subsurface safety valve. Like if you produce some X amount of oil from the ground with the pressure, the subsurface safety valve will allow the oil. If you increase some X plus amount, due to the high flow, the pressure, it means the pressure is also increasing. The subsurface valve will close and they will not let the flow of oil to safeguard any high pressure generation from the downstream. So they'll have some minor mechanical safeguard in the downstream. And they will also have the subsurface safety valve. They'll also have On the ground level, one possibility to close. They will have all these kind of safety systems usually.
Okay, sir. Thank you, sir.
Okay. Did they use any software in this technology? Yes, or okay. So software is everywhere. So in every design calculation, they have some like pipe sys, flow sys, high sys, and there are many software they use in any analysis kind of stuff. And for example, in terms of control, they have multiple specialized company-owned softwares. So today's world is driven by software. There is even like every industry is having twisted with software. Just to say, for example, right now they are seeing a way how you can sit in one place. Maybe I sit in Malaysia, but I will control a machine that is operating in France. So that is done with a lot of different kind of special softwares that is built in. So softwares is everywhere, and I would say the today's world is software. There is nothing different in that. Even chemical engineers use a lot of softwares. Okay, so you told using vibration to plot the graph instead of crude oil water. So you told using. Okay, so when we plot what is in the subsurface, if there's a water presence, it is only the exploration well. There is no other go. If you find the seal, the trap, if you find the porous material and you decided to drill, and after drilling, if you find only the water or very small amount of crude oil, by that time the companies will decide to close off the well and move ahead to another place. That's how it works. The exploration well is always a luck-based one. They'll predict and they'll do the drilling, and if it is present, it's a hit. If it is not present, it is not. That's all. Nothing doing. So even in India, you would have heard recently, India has given an open market alignment that anybody can lease a region and try to drill it, and if they find a well, then government will make an agreement with them. So because it like government cannot say you go there, there's a well, there's a place you can drill and take the oil. Government has to give a place, they will drill. If it's present, then they'll make an agreement. Otherwise, it's okay. It's not present. That's how it works. It's like water well. You drill in some place, you don't know what kind of water you're going to have on the ground until unless you touch it. So you showed the drill bit was going down in the carpet, how they control that. Okay, directional drilling is a technology that exists for last 10-12 years. In that kind of drilling, you will have motor just behind the drill bit itself. This motor is run by the mud. It is not electric motor. You inject the mud with pressure that drive the drill bit, and they will have a sensory thing that will move the drill bit head, and you will be able to control it from the ground. That is one of the expensive design. Otherwise, you will predefine which direction this drill bit has to turn after this many kilometer down. Based on that, this drill bit will turn its head and move underneath. And just to see, you are drilling more than 7-8 kilometers. The pipe of 6-inch or 4-inch is just a kind of hair. In that case, it will bend out without any problem. Is that okay? The answer makes sense.
Yeah, sure.
Who and at what basis the oil prices are decided? Okay. So any commodity by today's world, it is decided by the demand and supply. That is a normal economic rule. So the price of oil is depend on how much supply and how much demand it is. That's why you would have seen the OPEC countries are trying to control the supply side. So the oil producers can control the production so that there is a limited amount of oil available, and you are able to sell at the price that you are able to sustainably do the business. That's how it is. For example, if you have to drill a well in Saudi Arabia and operate sustainably, you need minimum of $15. If you are going to sell it lower than that, your operation cost will not match. You cannot sell lower than that. If you're going to drill a well in India, you need minimum $30. It is not going to work lower than that, because you have to pay salary for the people, you have to pay the equipments, all these things. So that's how it is. So you have a minimum operating cost that defines at what minimum price you can sell, but the market always does not pay that price. It depends on how much quantity available in the market versus how many people want to buy it. So how many people wanted to buy it? For example, in Reliance, they have a big team that regularly bid the oil globally and bring it to India. So that's a commercial organization that exists. So that's how it works. Every company that refining has that kind of team that bids to the producer, like maybe they will bid to the Saudi Arabian region or country or whatever it is. They bid to the oil producer and they import the oil. That's how it works. I had just had a small doubt. Won't the chemical engineering people face any kind of difficulty when they compete for the petroleum or oil and gas based job for a petroleum technology, and petroleum engineers should be competing? Okay, so this is a very difficult question for me. If a chemical engineer will compete with the petroleum engineer. Okay, just to be very frank with you, I would give you a recommendation to choose a job that makes you more interesting. For example, I landed in a job that as a process engineer, chemical process engineer. That is a core chemical job in a company named Technip. And I was there for 2 years. And when I moved to GE, I was doing a core chemical engineering job for compressors. But after 5 years, I changed my profile and I became a project manager. And I became a project manager for chemical project, of course. But after 5 years as a project manager, I moved to a role as a cost out leader, which is nothing to be done with the chemical engineering profile. And now I am a digital initiating leader that I'm taking care of a lot of software projects that for the oil and gas company still. Maybe I know how they operate. That's what it matters to me. But still, right now, my core job does not driven only by a chemical engineering perspective. My core job is driven by a business perspective as well. So I would say, don't think if there's a competition between different group of people. Maybe even chemical engineer can take a lot of mechanical jobs as well. It is not big difference because chemical engineer just learn extra as a chemistry compared to the mechanical engineer. We still learn the heat transfer, mass transfer, thermodynamics, everything similar to the mechanical engineer. So it doesn't make much big difference. For example, in the power plant, mostly the mechanical engineer sit as a process engineer, and even still, the chemical engineer can also do the same job. So it doesn't make any big difference. You can choose any job as long as you like it. Is that okay? Answer? Can I move on? In a seashore, how did they drill the ground and how did they will discharge the mud under the water pressure? Okay. So before they drill the well, they prepare the surface and they put the blowout preventer. The blowout preventer will have its own sealing arrangement. It will not let the water inside. It will have the mud that is injected through the special pipe. And it will be collected, the mud will also be collected back in a special pipe. The arrangement is like that, it will not let the water in. That's a design arrangement. Does that make sense? Or you want something more in that?
Yeah, I think Surya. Okay, so I think you can proceed with the next one, sir. Maybe.
Yeah, okay. In Saudi Arabia, Dubai, the temperature is high, sir. How the drilling will happen due to the high temperature, the mud may got failed and okay. The mud engineering itself is one special stuff. It is not just like if the Saudi Arabian temperature is high, the mud engineer has to choose a chemical that will withstand that temperature, that will have that kind of density even under the ground. So that's a mud engineering. That's why I call there's a mud engineering team that decides that designs chemical that will provide the density and viscosity and the heat consumption pattern based on what we need. So that's a chemical design team. And they design the mud and they design the chemical, and they also make a prototype manufacturing facility, and they give the technology transfer to the organization that can manufacture it. Sir, you said earlier the chemical engineer have a minor role in upstream company as compared to the downstream company. Then how ONGC records chemical engineer? Okay. Yes, I told there is. I doesn't told there is no role at all. I told comparatively the number of engineers present in the downstream industry is much higher compared to the upstream industry. So when I say ONGC or GAIL, they are predominantly upstream company. If you compare how many mechanical engineer they hire compared to the how many chemical engineer they will hire, you will come to know the difference. So basically, they also need chemical engineer. I doesn't told they does not need a chemical engineer. They also need a chemical engineer, but the level, for example, if you have to have a pump downstream the well to push it out, you will need a mechanical engineer to design and develop the pump. But you will need a chemical engineer to tell how this pump has to operate, what should be the suction capability, how much it should push, and how the design should be there. It need a chemical engineer, but to design and develop, you need a mechanical engineer. That's how it is.
So,
Yes, Gauri.
Yeah.
So, what is the use of geoscience software, sir?
Geoscience? Can you repeat? Software. I have not heard of it. Maybe like geoscience is a team. They may use multiple different kind of softwares. Like they are trying to find what is under the ground without drilling the ground, and they have a seismographic system, and they use any kind of software that they develop for them.
Sir, can you give me some example as how chemical engineers is involved in site activity installation?
Site activities and installations. So basically, if you are installing a compressor, you need a chemical engineer for startup activities at least. So when you are going to start the equipment, you should know how the compressor operates, and you should plot the operating point, and you should bring the compressor to that operating point and stabilize it. That involves the chemical engineer usually.
Thank you, sir. Thank you so much.
Yeah, Vignesh has raised his hand. Yes, Vignesh. You can unmute and you can talk. Vignesh, I think your voice is breaking.
Hello, sir. Can you hear me, sir?
Yeah.
Yeah.
Hello, sir.
Yeah, I can hear you now.
Sir, can you suggest best method for vacuum distillation, sir?
I have not specifically involved in that kind of projects, so I'm not good expert in that. Sorry.
In future, I'm planning to manufacturing of organic phenols, sir. So vacuum distillation is needed. So I want to know more about that.
Maybe you have to find a right people that maybe that may be involved in the vacuum distillation designs.
Okay.
From my side, actually, I have my core experience is in safety design system for the big engineering projects. Plus, I have involved in compressors, gas turbines, steam turbines, those kind of special equipments, valve manufacturing, those kind of stuff. Maybe on terms of this kind of distillation system, I don't have any experience at all. Just very frank.
Okay, sir. Thank you.
Yes, sir. I think it was a very good session. I think we can see that's why lots of questions was pouring up for your session, because that itself shows that the students have much interested, especially on the upstream and downstream of our oil and gas field. So with that, our Institute of Engineers, Tvlc and Ursagosolutions, thanking you so much, because I think this is again the second session you have given to us, like from the Ignite 1.0 and the 2.0. Definitely, I think especially the chemical engineers who are sitting here. So I think they are all final years. Maybe another 6 months they are going to step into the next level. So these informations definitely I think they could have not learned from the syllabus or from the classroom. So that's what I think they got a very good knowledge, and definitely I think that they will utilize this kind of knowledge for the coming days, which will also motivate them and will raise the confidence level also.
Thank you very much, Gokul. Thank you very much for the opportunity for me to transfer the things that I know to some extent to the students. Thanks for arranging this forum. Thank you very much.
Yeah, definitely. And I think even if you want, you can give your mail ID in the chat box, so that anybody who have any contact, I think they can even mail it to you.
Yeah, I'm just pinging my.
Yeah, just there in the chat box. So maybe any of our intern wanted like any more further queries or anything mentoring, definitely I think Pandiraja sir will help you out. And especially I think he's alumnus of Sriram.
Thank you. Thank you very much for the time and opportunity.
So
All the
definitely I
best for all
think
the students.
you can involve and you can able to make good kind of alumnus relationship is very, very important. That's what all the speakers was trying to say for all of you. So connect with your Pandirajan sir to your college also, so that he can able to give much more detailed knowledge sharing and wisdom for the budding engineers who might be your juniors also. So with this, thank you so much, sir, Pandiraja sir, for joining
Thank
and
you, sir.
spending your the time of with us in the 12th of November. Thank you so much, sir.
Thank you. Thank you very much. Thanks for the opportunity.
Yes, sir. Thank you, sir. Thank you, sir. So I think okay, for all the interns, I think as we already said, there's going to be a feedback session. So I request all of you please come in the video mode, so that we can have some feedback sessions for last 12 days, how the session was there and how it is made. So which one you are rating it like a best one, and what is the improvement you wanted from us? Can we see all people in the video mode? Yeah. Maybe still, I think many more. I think only 4 people are there in the live, or because all the people to come in the video mode, so that we will know that you people just not switching on Zoom and going somewhere. So you're also listening it. So we wanted all of you. Then only like then an announcement is there. Maybe I have to read the names. Maybe Surender, Maniarasan, Aji, Anantakumar. Can just okay. And Asai, Achaya, Bharat Kumar, all the Bharat, Barkavi, Gokul, Hari, Harini, Hemnath, Jai Ganesh, Jai Praveen, Joseph, Madan. Just come on, make it fast. I think switching on video is not so easy. It's going to take a minute only. So that one important thing, I think you people, I think are only like sitting in the Zoom. Maybe you people don't know about who are the other interns also. So that you can able to view them, because you should not be always in the virtual world. Virtual world should be connected with the face value also. So that that also will make them good. Okay, all the people are there. Okay, if somebody is having problem, no issues. I think Surendra has put up. Good. So I'll just like the feedback from. So I think yeah. Other than feedback, I think people can mute. They can come in the video mode, but you can mute it. I think who is not. Subhashri ma'am, please note down who are all not in the video mode, so that we can rate them the certificates in different manner. Still, they're not opening it.
Sir, I couldn't able to open video, sir.
Who's speaking?
Surender, sir.
Surender, okay, that's what we have understood.
Okay, sir.
Anybody is not having, I think they can put a message. Otherwise, it is mandatory to open it. So the list of people, I think we can able to give it to your HODs also. Because you people are going to step into the next level of interview. Still, you are going to hide yourself. I think it's going to be very difficult to cater this ball. So that maybe if you come out and you can see other people and you can able to give your feedback, it will be good for us. So yeah, we will start up without not wasting time. So I wanted 5 people. So you can unmute yourself and you can give the feedback of last November 1st we started, and today is November 12th. So 12 days you had a session. If you take each session 2 hours, so I think almost 25 hours you have been involved with the various people. So you can just give a feedback, and you can also rate the session which you liked it best and what improvement you wanted. Maybe each people can take 2 minutes.
Sir, can I give a feedback, sir?
Yes, Babin.
Yeah. Good evening, everyone. We have reached the end of our internship. I came here
You
to.
can even introduce your college name also. Many of you might not be knowing.
I am Babin from Sriram Engineering College. I came here to share a few words about the feedback. Each and every students were very thankful for the Inter Monsoon Group, IEI, TVLC, and Ursagosolutions to give the Monsoon Internship 2020 and Ignite 2.0. It started on November 1st, 2020, and it has successfully reached the 12th day of the internship. Until today, Sir D. Gokul, Head Chemical, IE TVLC, Dr. J. Balamurugan, Community Member, TNSC, and Dr. G.R. Subhashri Ma'am worked hard for us to give this monsoon internship. Thank you, ma'am. Thank you, sir. We got 11 different speakers in 12 days, and we have learned so much from them. How we have learned how future chemical engineering will be and how the placements for will be for us and so on. Each and every staff gave their contact number or Gmail to contact them anytime. They are very friendly to clear the doubts for us. And all the students got a project in Green 9 SDG 713. We were very thankful for this internship to give us a project, sir. Very thank you, sir. Once again, I am thanking for all staffs. They made the internship successful.
Babin, which session you liked it? You want to rate it?
Yeah.
If I give out of 5.
Sir, which session means? I can't understand, sir. Which?
No, daily, I think you had one session. You want to mention any speaker like I learned much more from this session. Like for example,
I have learned a speaker from Kanyakumari. Because I am a person from Kanyakumari, so I learned such some green, eco-friendly things from him. So that I am very interested to join his project. I am very much interested in his speak.
Like Professor Ramesh, you are saying.
Yes, sir. But I am not. I am interested in everyone, but especially I am saying him, sir.
Yeah, that's fine. That's
not
fine.
Others were like this.
No, I know. So that's what I'm just asking the rating. Like if I give, if you want to give 5 out of 5, other people you can give 4.9 out of 5. So for you, for him alone, you'll give 5 out of 5.
Yeah.
Okay.
We can give everyone 5 out of 5. So for him, I will give extra 5.1 like this.
Okay, great. So fine. I think thank you, Babin. I think your wonderful feedback. We are taking it up, and I think maybe you, as you said, I think the projects also. I think Subhashri Madam will be coordinating with all of you. They are forming the WhatsApp group. Definitely, I think we will initiate the project very fast, so that all of you will get an opportunity to do some projects other than your main projects. Main projects is something you're going to do in the next semester, January onwards. But this will be helpful for you, I think, as a mini projects and also for your placement oriented. Thank you, Babin.
Yeah, thank you.
Can we have second intern who is ready?
Sir, good evening all. I am Sheetal Chandrasekharan from Satyabama Institute of Science and Technology. So the most, my favorite session was Subhadra ma'am's session. Like her session was very informative. It was very interesting. It was very interactive also. And the first session, the very first day, it was very impressive. Sriram sir had was the speaker, and he was talking about the carbon neutral. So when we discuss about some general topics, usually we'll feel more easy to go. So the first session itself had impressed all of the interns. And also Nagarajan sir, his lectures were it was very informative, and his lectures were also useful for my exams. Like I'm a third year student, so we are having this process engineering subject in this semester only. So his lectures had created a great impact on my exams also. And Prakash sir, I think he handled on the 5th day. So his session was also very informative and very interactive also. So when the session gets interactive, automatically the session is very interesting. Like it pulls all the students to learn more. And also yesterday Manuraj sir had taken the session. So I felt like he was a multitasker. In fact, he was talking about water resource management, and then at last he was talking about the stress management and all. So both has different variations and all. So when when I got to know about him, I felt like it was an inspiring thing. And also I would like to thank Gokul sir and Subhashri ma'am, Balamurgan sir also for conducting this event, this internship. So we all know that talent and capabilities are of course necessary to bring up more right and backs that go so India is also a very important aspect in every degree programs. So it's a great privilege for me to join this session. Thank you, sir.
Thank you, Shetal, for your valuable feedback. Definitely, I think you can even, like, as you're the third year, I think even one more year is there. So much more we'll plan it up through the society. You can also join in that. Thank you.
Yes, sir.
Yeah, who is the third intern? Yes.
So, I'm Arun from Sriram Engineering College, sir.
Yes, sir.
Sir, I would like to thank each and every coordinates and directors and technical directors, everyone, sir, and co-interns also. My most favorite and favorite topic and also session also took Nagarajan sir, introduction to process engineering design, sir. That was amazing and very informative. uh, I would like to go forward with that topic in my future, sir. Very useful, very interactive. I like it very so much, sir. Thank you, sir.
Thank you, Arun. Thank you so much. What about Agni College? Nobody is there. Agni and Dhanlakshmi. Yeah.
Sir, I'm Rashika from Satyabama Institute of Science and Technology. So I'm
Yes, sir.
currently studying third year. So till now, we've been learning subjects about chemical engineering only in a classroom mode. We didn't have opportunity to get to know about the journey of all chemical engineers. So this in turn really helped to know about the journey of every chemical engineer, like starting from their studenthood to the present stage they are. So it was really good. And the session I liked the most was Swarnalata ma'am's on operator training things. So she made the session very interactive and very interesting. It was not very plain. She was very energetic till the end, and it gave inspiration for young engineering girls like us. So thank you for the opportunity, and thank you for even Subhashri ma'am and you, sir. Thank you.
Okay, Rashika. Thank you so much for your valuable feedback. So yeah, another two more. I think I wanted one from Agni, another from Dhanlakshmi College also. Who is there? Anybody can open it, but specifically I wanted these two college, anyone also to talk.
Sir, I am Surendra from Sriram Engineering College, sir.
Surendra.
Sir, I mostly like Swarnalata ma'am and Subhashri ma'am session, sir, because they.
Ma'am has not given any session, Surendra.
So, sorry, Subhatra Rajendran, sir.
Okay, fine.
Okay, sir. Sorry, sir.
Okay.
They speak very useful to us, sir, because they explain real time explanation, sir. It's very useful, sir. At the time, they give some more courses to learn everybody. The interaction is very useful to us, sir. Thank you, sir.
Thank you, Surendra. Thank you so much. Yeah, maybe Agni, nobody is there. Okay. Or
Sir,
Dhanlakshmi, yeah.
I'm Gauri from Agni College of Technology.
Yes, Gauri.
Every sessions was very interesting. I loved Swarnalata ma'ams and Subhatra ma'ams because it was very interactive and very interesting. The way they spoke was very comparatively to others. It was very interesting, and every session was very useful for our final years because this could be very helpful to learn more, which will be very useful for our interview, sir. Thank you, sir.
Thank you, Gauri. So maybe last one we can get it from Dhanlakshmi College. Anybody is there?
Sir, can I speak?
Yes, please go ahead.
Sir, I'm Magesh from Sriram Engineering College.
Yes, Magesh.
Sir.
Magesh, please proceed.
Yes, sir.
Maybe your network is down, I think.
Yes, okay, sir. I will correct, sir.
Good evening to all in the meeting. It is my pleasure and honor to facilitate the internship program. I would like to thank Gokul sir and Subhashri ma'am for the effort towards the internship coordination and because of the big foot ahead enhance our knowledge and skills. We also thank our beloved guests for the enriching our knowledge, and we feel the teacher and it's big honor to how a bunch of graduates. Thank you.
Thank you, Magesh. Thank you so much. So, last one from the Lakshmi College. Anybody is there?
Sir. Sir.
Yes, please proceed.
Sir, I am Mohideen Marzuk Muhammad from St. Joseph College of Engineering, sir. I thank you and Subhashri ma'am to conduct this wonderful event, sir. And among the 12 days, I like the most event is Subhashri ma'am, non Subhatra Rajendran, who has organized how to proceed after degree, how to enhance our knowledge to enter into the industry. I have learned many things about in that session, sir. So it is so informative for me to have a wonderful session, sir. Okay, thank you, sir.
Thank you, Mohideen. Thank you so much. I think I know you are the only youngest person. I think you are the second year. Thank you so much for making this.
Second year, sir. So it is new for me to learn everything. It may be
Right.
For every major I want to learn after this. So it is a very good base subject for me to learn in this internship, sir.
Thank you. Thank you, Mohideen. Thank you so much.
Yes, sir. Thank you, sir.
Yeah. If furthermore no anybody is there, last one.
Hello, sir. I am Vignesh. I am Vignesh. Good evening to everyone. I am Vignesh from Sriram Engineering College, sir. I like all webinars, and they give more knowledge for the young students. We have learned more knowledge from the experienced persons, from higher level professionals. We got more knowledge. I have learned many things. Through these sessions, we come to know that how chemical engineers play important roles in this world. How the world needs, how chemical engineers necessary to this world, and it's chemical engineers' duty to save our environment for the future generations. I like to thank Gokul sir and Subhashri ma'am to arranging for giving this wonderful opportunity to our final year students. I hope all students gets inspired and achieve their goals in future. Thank you, sir.
Sir, I'm Gauri Shankar from Satyabama Institute. I wish to express my gratitude to you, Gokul sir, and Subhashri ma'am and Dr. J. Balamurugan, committee member of TNSE, and all the speakers for the valuable knowledge and the guidance and support. My favorite session is energy conservation from the hands of engineer, handled by Ramesh sir, and he has given 2-in-1 opportunities, and it was grateful, and I was so grateful to be a part of this internship.
Okay, Gauri. Thank you. Thank you so much.
Sir, Santosh is there from Lakshmi College, sir.
Santosh, yes. with Santosh, we can close it up. Santosh, I think your voice is not here audible. Not audible, Santosh. Maybe there is some problem in the mic, I feel. Okay, Santosh, no problem. Okay, for all of you, I think internship is not over, so we are just continuing it. Don't worry about it. I think still we have a few more days to continue that. And Santosh, you can give your, I think, feedback. Yes, Santosh. Okay, I think you still, I think there is some problem in your audio or mic. No issues. So for all of the interns, thank you so much. I think almost 12 days. I think the cooperations and the professionalism what you shown is really great, because we didn't find like no disturbance was there, and every session has gone on time, and the QA sessions what you people have done is really extremely great. But I know like you're all final years, so that's what like many like the speakers have given you much more confident. Still, I think you need to come out, because the competitive world is totally very high, and it's not so easy to get any kind of job or opportunity very easily. It's like now your real engineering fraternity is going to come out. Definitely, all people can achieve. So it's nevertheless, I think you people have studied for 4 years. Definitely, you're going to be placed in a very high position. So I think by I think next 3 days we are just giving an off. There is no intern. So for the Diwali, so like an advance Diwali wishes for all of you. So we will start up from again from Monday, so that I think a few of your HODs might be communicated that we will be interacting with directly with the industry also. So that is what we are extending our internship. Maybe 2 to 3 industries we are just tying up, so that we will have a direct live, or they'll be recording it and they're going to say about the processing industry. Because of COVID, I think we cannot step inside any of the industry. At least they can step inside our Zoom. So that is what we are trying to do that. And also we may have like one session from sim info system. So they are going to like give a live software simulations, especially on the chemical process industry, which is going to be happen next week. So that is also we are in the talk. So definitely it is going to be there. And we have one session on the batteries and energy. So electrochemical, since we are chemical engineer, I think that's something allied industry we can say, not like a very core, but it is very important sector, because the battery industries and electrochemical industry going to have a very big boom because of the EV vehicle which is going to come out. The electric vehicle policy level, I think government is going to take care. Maybe you people, I think when you're going to come out another 2 3 years, when you're having a very good amount of experience, definitely the EV vehicle manufacturing of the batteries and the lithium ion, so many new things are going to emerge in India, and you are going to play a very big role. So we are going to have one session on that. So maybe next month, next week, we will try to complete with all the sessions. So that these 3 days no intern, so that you can able to have a very happy and safe Diwali, so that we can meet you all from Monday onwards. So the same timing, evening only we are going to have it. And 2 to 3 industries we will try to bring it up in a live the session, so that you can able to handle it. And regarding a few important, that is like an assignment, I think people are interested. I think whatever the Prakash sir has said, I can give us the contact details, so that you can able to talk to him and you can do it. That is a value added for you, because doing some assignment always will make you a good amount of knowledge to grab, and the involvement on the assignment will make you some more information to learn it. And also the project, I think Subhashri ma'am will be coordinating today to you with all you people, and we are forming a WhatsApp group. And with that, I think we will initiate the project. Even after the internship over, also the project will be continuing it. So whoever completes and whoever willing to give a presentations to the IGEN, that is Institute of Green Engineers, you can do that. And accordingly, your projects will be like awarded and rewarded with certificates and the medal. So that also try to grab it. So because the COVID, I think you were like sitting almost in a four walls. You could not able to go much out. Maybe last 1 month or 2 months you'll be going out. So still use the opportunity through IGEN, and you can grab the facilitator given by this internship also. So with that, I think we are just closing up. And from Monday onwards, the same feedback session will continue. I wanted all you people to come in the video mode and interact yourself for the each session, because from 1 to 12, I think you people have given it. Whoever not come in the video, I think Monday onwards, we want you people to come inside the video mode, because you need to show yourself to the outside other intern also, at least what you can able to do that. So I think Santosh has right. Santosh, yes, you can give your feedback if your audio is okay. Santosh, still I think your audio is not visible. Or Kirtana want to say something? Fine, no issues. I think we can even continue our feedback session in the coming days. There's just an initiation only, no problem. So with that, I think we are closing up, and maybe Subhashri ma'am, you want to say anything, ma'am?
Sir, I just want to thank Pandirath sir for that crisp session, and thank you participants for accepting our request. Thank you, sir.
Okay, fine. So let us all meet you after Diwali. So have a happy and safe Diwali. So enjoy the days, and we'll back on Monday with new more sessions added up on the software and the industry interactions, and 1 or 2 sessions on the chemical core subjects. So that next Saturday we'll complete. We'll have a validatory. With that, we'll close that. And after your session over, from the day to 10 days, you can submit your report. So once you submitted the report, your certificates will be given. Also, there will be a best top 3 or 5 internship will be also be selected based on all your performance, whatever you've done from the day 1 onwards. So with that, thank you so much. So let us meet you after 3 days. Thank you.
Thank you, sir.
Thank you. I'm closing up, ending this.